All right, how's it going, everybody? Happy Friday. And let's see. So today, if you're just joining in for the first time, today I'm going to be working on the Compose compiler, and this is, in particular, we're working on a project that I call Stable Inference and Propagation. And we've been working on this for 2 weeks now or something. I've been streaming most of the work, and if a lot of like the context for it is maybe hard to get. So if you're not following along as we're going, the first episode in this series goes over a lot of the details on why we're doing this and what the motivation for it is and stuff like that. So definitely go check that out. I can probably let me pull up a link to that video. I can add an @state. Okay. So I'll post a link in the chat to that video, and the first 30 minutes to an hour of that video go over a lot of like the thinking behind what we're doing and all of that. So let's go ahead and get started. I'll kind of catch people up to speed versus what I was doing last time. Basically, so on Wednesday when we were last working on this, I was using this descriptor serializer plugin to add a property to the metadata so that we could call it from other modules. And after chatting with some people, I think that this is probably the wrong approach. So I'm probably going to scrap this class. And one of the reasons is because the metadata is like built in this protobuf, and the data format that it has is like very much it's very specific to like what is kind of natively possible in Kotlin. And the type of property, like we're trying to put a static final int on virtually every class in a compilation unit, and in Kotlin you don't have static fields or anything like that. So the way in Kotlin to get that would be to have a companion object and then have a const or a JVM field property on the companion class. And that means that I would have to end up generating a companion class for every single class, which would like double the number of classes that we have. And so I definitely don't want to do that. So one of the things that I realized was, actually I didn't realize, one of the things after discussing with some people who who know the compiler pretty well, we ended up deciding that a better way to do this is actually just to add an annotation. So I added this stability inferred. So I added this annotation. And all this is doing is basically like marking a class as being stability inferred. And this is only ever going to be leveraged by the compiler. So this isn't an annotation that anyone's actually going to use directly. And what I'm doing then is once we mark the class with this annotation in the backend, so that'll actually show up in the class file, which you can kind of see here. So this annotation shows up now on this class. And in another module, what I'm going to do is I'm going to look for that annotation. And if that annotation exists, then I know essentially that this field will exist, which isn't static anymore, but it should be. So I changed that. So now what'll happen is we'll see this annotation, and then we'll basically add the field to the class again, even though it's just the stub from the other module. We'll just add that field just to kind of fool the backend into believing that it's there, and then we'll generate a call to it. And that's basically all we'll do. And I think that should work pretty well. So kind of fingers crossed, I think that this is like the final piece to kind of connect everything together and get what we need here. So we should be able to make some good headway today based on that. So let me know if any of you have questions about that, or if that wasn't clear. Okay, so we're adding the annotation, so that's fine. And then I think what we're gonna do now is in the so when we're trying to determine the stability of a class, let me pull it up. Stability of, so here we are. So when we're determining the stability of a class, we'll end up here at some point. And so here it's, at this point, the class itself is like an external stub, which means that it came from another module. And so now what I want to do is I just want to check to see if it has this annotation on it. So let me create a function for that. So I'm just going to follow the same kind of mechanism here. So it'll say has stability inferred annotation. And we've got that. So this is the fully qualified name of the annotation. Okay, so now we'll say operation has stability inferred annotation. So if it does, then we return uncertain, because basically what this means is now we're not certain that the class is stable or unstable, but we can figure it out because of this annotation. It should have a static final int on the class that indicates whether or not it's stable, and so we can figure it out at runtime. But if it doesn't have that annotation, then we can just return unstable, because at this point there's no way to resolve at runtime if it's stable or not, and so we just end up removing it. Hey Dev Souza, how's it going? So and what we'll probably want to do, so at some point as we get further along in the project, there might be some classes that we want to infer correctly that won't fall into one of these buckets. You know, there might be some standard lib classes, for instance, that we know are immutable. So they'll end up in this IR external declaration stub, but we know that they're immutable, so we can go ahead and mark them as stable anyway. So Dev Souza asks, you done a stream yesterday? I didn't do one yesterday, but I did upload a YouTube video yesterday of the stream that I did on Wednesday, because for some reason or another it didn't end up correctly streaming to YouTube. Okay, so now we know that this the stability is uncertain for these. So this is where like our class is going to end up, is in here. And actually what I want to do is I think this is a good time to add that field to it, or like, so basically instead of just the declaration here, we could say stable field, and this could be a field symbol. Yeah, and I think that'll be kind of enough for us. So oh yeah, you saw a notification from it. Well, that's good. I'm glad that, you know, YouTube notifications are working. Hopefully I'm not like overloading your feed with live stream notifications. So at this point, this is kind of what I'm looking for then. So build field, kind of gonna duplicate this. What I might do is I might create like a basically like a little helper to create a new field. Make stable stability field. And then so this is going to be the same for everything. And then so basically we can, well, I guess we'll do this because we don't actually need the initializer. We don't need the initializer when we're just generating the stub. So this is enough. And then here, like, so we'll want to set the parent and the initializer anyway. So we can just say make stability field and then set this. And then in here, what I can say is I can say val field equals make stability field. And I can have the parent of it be this class. And then now I can pass this into here. I guess I made it a symbol, but maybe I should just make it a field. Okay. Does that work? Yeah. Asher asks, is it just me or do you look different today? Maybe. So I haven't a little bit of personal information. I have not showered yet today. Well, I showered last night, but I had a kind of a crazy night. So my wife and I were like going to bed. It was like, I don't know, past midnight, like maybe 1 a.m. or something. And I let my dog out to go to the bathroom and it got sprayed by a skunk. So, it was a long night. I had to shower my dog last night, and just our house smells. it's terrible. So so that was fun. But I normally shower in the morning because my hair gets all crazy. Well, actually, it doesn't look that bad right now, but normally my hair gets crazy if I sleep on it. Yeah, he's okay. I think he was a bit flustered, and he definitely still smells a bit, but I think we got a lot of it out. Yeah, so it's funny. It's one of those things where, yeah, tomato bath. We actually used our last can of tomato sauce for dinner last night, so that was bad timing. So we had no tomato sauce or hydrogen peroxide, which is also recommended. And it's weird because I think that you get used to the smell somewhat quickly. And there's like I was kind of walking around the house and I was like, oh yeah, you know, like it doesn't smell that bad. And then I went outside again for a little bit and then came back inside and was like, oh, it still smells. It still smells like scum. All right. But okay, so here we are. I think that this is gonna do basically what we want. We're creating a new field that looks like a stable static final int, and we're marking its parent as the class. And then what's going to happen is that when we want to call it or like get the value of that field, we'll have this stability instance, which will have the field, and then we can call that. So I think if we go here, so this is where we want to generate like the expression. So in this case, we don't need this. So we're generating an IR expression for whether or not something is stable. And so we've now run across this uncertain type. And what we're gonna do is we're gonna get a field on it. And then we'll use the stable field symbol. Well, yeah, okay. So import that. All right, and so now we've got, I wonder, I think I have like a IR get stable field. Will this work? No. All right. Yeah, I don't have like a little shortcut for that, so this is good enough. And then we shouldn't have to do this if null thing. So that should be enough. Okay, interesting. So this kind of works right now. It'll give us that field, but then I wonder if we need to shift it. I guess we can do that somewhere else. Okay, so I think this will be good. Okay. Yeah, so you can see that we use it here. So this gives us the OR expression. And I think what's gonna have to happen is that we're gonna have to do something like this. We'll need to shift the bits a bit. Let's see what happens here, and then we'll deal with the bit shifting in a bit. Okay, so let's let's go to our test. What I want to do, fun. So what we can do is just pass in a foo instance, and that should, like, what this means is that the type of this argument is going to be of type foo, which is a type that we've defined in another module. And so that type is going to have the stability inferred annotation on it. And when we generate this, what we should do is we'll create some expression to pass into the changed parameter that, like, it looks at foo.stable basically to see if it's there, or to see what its value is. So let's try that. I'm looking through the comments, and Syed Mominzaid asks, have you considered something like Flutter boring show? What does that mean? I don't know if there's like a joke here or something, but I didn't catch it. Also, hi Sergey, I didn't see that you said hi. Hey Sky Color. It's funny how much longer these tests take to run on stream, just because my processor's doing a lot more. Okay, so there's the first class. It gets generated with the final int and the annotation. And it looks like I forgot to import something. Okay. Not Kelset. Is that how's it going? Flutter Boring Show is a 1 to 2 hour long show they have on their YouTube where they build or show new stuff unscripted. Kind of what you do. Okay. Yeah, I don't know. I mean, so what are you asking me to do something like that's a little bit different from what I do now? Or what do you think? So not Kelset. Is this Lorenzo? I don't know anyone else that goes by Kelset, so I don't know. I'm assuming it is. Ah, thanks. Yeah, I appreciate it, man. Good to see you in here. Okay, so let's see what happened. Basically, what we want to see here is when we call, so here we're calling A. And interesting, it actually put so it's BI push 8. So I'm not sure if this worked or not. I mean, so it's loading the constant 8. So like what this ended up doing is this, which I'm not sure if that's right or not. I don't think it is. Because we want it to do, like, we should, instead of BI push 8, we should expect like a get static, and it should be like, you know, a/foo dot $stable or something like that. So let's go ahead and let's run it, but in debug, and then let's put like a breakpoint here. And then also let's put a breakpoint here, because 8 would be unstable, I think. So it sounds like it went down this path, which is not what we want. So it seems like this annotation didn't make it in. I'm not sure why. I thought the annotation would have. Thanks, Alejandro, for the the vote of confidence there. But yeah, I mean, so Syed, if there's something like from that show that you think like it would be cool if I did or something similar, let me know. I'm always interested in some new ideas. Too many, oh, because I changed it, so. So I wonder if when I add this annotation to the class, I wonder if that's like, that's not enough. I don't think we've added an annotation to a class before in IR. I'm not sure. Okay, yeah, so we ended up here. So right now this class has no annotations on it. So that's a problem. So we've got to figure out how to add the annotation here. I'm surprised it doesn't have the annotation, because I thought that that would be populated from the class file and not the metadata. But I don't know, maybe I'm wrong. So, I mean, maybe we could use this, we could use this extension after all. Yeah, in the bytecode, the annotation's there. And so the thing is like these, the IR class here. So this thing, this is, so it's like this IR external declaration stub. And so like, it's not the full IR class. It's like a stub that was generated. And I think that generation happens mostly from the metadata. But I mean, they get the metadata from first looking in the class file. And so I thought that they also grabbed some information from the class file. And I thought that annotations were one of those things. But I could be wrong. So I don't know. Can I do like add? Yeah, I don't think the annotations are in the protobuf, so not sure. Like one of the things that's a little bit weird, I think, is like where is it here? I mean, so I'm adding on to this annotation, but this is IR mutable annotation container. Okay. Okay, so this does a set carrier. So that seems correct. Like that's what we want. So Andre says they do get some info from jars, but IR stubs are mostly generated from descriptors. Okay. But the descriptors, yeah, so the descriptors themselves are deserialized from the metadata, and that's how they're created. But so Yannick asks, hey, well, she says, does the fact that the analysis runs on the backend, after all, means that we won't get the info in the IDE? Yeah, so I did talk about this last stream, but basically we were kind of forced to go down this path. It doesn't seem like there's a good way for a compiler plugin to pass like this amount of metadata from the front end to the back end. The mechanisms to do that have kind of been removed or are deprecated, and so like the descriptors and stuff we're not able to use in the backend. They're now deprecated, and so I'm trying to make a solution that doesn't do that. And that unfortunately means that we're going to do this analysis in the back end, and that we probably won't be able to surface this information easily into the IDE. So it's unfortunate, but it's just, as far as I can tell, it's kind of the way it's going to have to be. Okay, so I mean, the thing is like if the protobuf doesn't have a space for annotations, then it can't. There's no way that information is coming from anything but the class file. But I don't know. Let me check. So like the descriptor serializer. Let's see, like, where are the annotations? I see. Oh, so it asks, has annotations. Interesting. So I wonder if it's not picking it up because this has annotations bit is like set to false, and then it doesn't look. That could be. So like to test if we so like I wonder if I did something annotation class bar and did this. I wonder if that would do it. Just as a test. So then what we could do is our yeah, basically we could use that serialization extension to just flip the has annotations flag, which I wonder if that'll have an impact on performance if like the front end needs to look up annotations for all these classes. But I don't know, it's probably not a huge deal, but it is something to think about. Darn. Okay. Well, so the annotations still ended up empty. Oh, well, I guess I need to put binary retention on it. All right. Guess those are built in. So I'll do that, see if that works. Hey, Rashawn, how's it going? Darn, still not there. Well, that's weird at this point, because oh wait, oh, this is the wrong, this is any. Ugh, well, I wonder if the other one. Okay, so this is now using this correctly. All right, so I wonder if this will. So Rashan, so we're working on the stability, inference, and propagation on the compiler, and so this is like a kind of like a bigger project that I'm working on. I've been streaming a lot of it for the Compose compiler plugin. Okay, so let's see what we see now. So it's still just. So there's still no get static. But I'm not sure I understand why. Also, I don't see the annotation. Right? This annotation's there, but what about the other one that I added? I'm gonna like, hold on. So I'm gonna make this non-restartable just so the bytecode's a little bit easier to read. And then so I mean I'm gonna keep this how it is because it did like work in the sense that it ended up going down the right code path, like that breakpoint got hit, but I'm confused about why more did not happen. So, oh, wait, okay, yeah, so I added it to the OR expressions. I think we need to set a breakpoint here and see what's happening. So yeah, I wonder if it would end up there for some reason. So is this running? Yeah. Okay, there's our class. Okay, this is just getting the stability. And so we're adding that field. That's good. So now we're in here. Okay. So when we get here, we should have get field. Oh, this isn't getting returned. Well, that makes sense. Right? Oh no, it is. Okay. Yeah, it is. All right. So this is the field. Got the right parent, static. Okay. So when we're here, we've got our get field, so or expression, and the bitmask constant is 0. So that's our result. Dev Souza asks, do you know if there's any Markdown renderer for Compose? There's not from like Google. I think I saw some project that someone made that like it used like some Markdown parser. It should be pretty easy to make. So let me see. Those Markdown. So yeah, I mean, it looks like someone did this already. Using Common Mark, which I've used like the Common Marks implementation in other languages. Yeah, so where's the link? I'm not sure, did he open source it or anything like that? Yeah, so I mean, it looks like it's not open source as a library, but like you can essentially follow the code in here to do the same thing. And this is, it looks like this is basically what I would do if I were trying to do this. So, yeah, that makes sense. Paragraph. Okay. Yeah, I mean, there might be some things in here that are like left to implement, but overall, this seems like the right way to do it. And so I would use what's here. You know, you might want to ask Eric if he's interested in like open sourcing it as a library, or if you needed it, then you know, maybe you could ask him if you could do that and if he would mind or something like that. But seems like this is a pretty good start. Okay. So I mean, this all looks like it's gonna work. So I'm a little bit confused. Let's see what happened here. See, I don't know why this is still doing, or is it here? Oh, I wonder if that was like an outdated thing. Yeah. Shoot. Okay. So this is actually what's happening now. And so this is doing the right thing. This is doing the get static. So this is good. This is great. Now let's see if like if we take away this annotation, is it gonna fail again? I think it will, but let's just verify that because now I don't feel confident that like that was the issue. So if I do that, do we get the equivalent result? Is this how we should do code reviews? Yeah, I mean, someone else mentioned this the other day, that they thought it would be interesting if for a stream, if I did some code reviews, like code reviews that I would otherwise be doing for my job, but just live streamed. I'm not sure I love that idea. Like I think it would be cool, but I would want to get like permission from people involved. Like I don't want you know, not that I would review code and like, you know, just be like, oh, this is terrible or something like that. But I think it would be unfair to review someone's code unsolicited live. So I don't want to do that without people saying that it's okay first. And then, so like maybe if people sent me like a PR or something, and like I could review their code potentially if they asked for it. You know, if that seemed like interesting content, that would be totally fine with me. But doing like the internal code reviews of, you know, colleagues and things like that without them signing up for that, I don't know about that. Okay, so this reverted back to this like BI push thing. So now I'm gonna try something. I'm gonna go to whoever's code I was reviewing, I would want them to agree. So let's add this serialization plugin back in, and then we're not going to do this anymore. But let's just do this. So for what did we do before? Let me just go in here and find it. Okay, so here are the class flags. We basically want to do something like this. And then I wonder if there's like a class flags. So I wonder if I can do proto.flags merge flags. So what I can do is so if I say proto.flags equals proto.flags or no true. Is this public? Oh, it might not be. Oh, and then this is not valid. Kotlin. Let's see. Yeah, okay. So that should work. And so let me just do this as annotation flag. Let's do that. And then I'll say if proto dot, because I don't know, I mean, based on this, I wonder if like setting flags is expensive or something. I don't know why it would be, but I'm just gonna follow their convention to like guard sets here. So I'll say if proto.flags and has the annotation flag is not 0, then do this. And basically what this is going to do, like unfortunately, I guess, is every single class in this module is now going to have the has annotation flag set to true, which, I mean, there might be some cost associated with that. I'm not really sure. So yeah, regarding this like code review thing, if anyone watching has like something that they think that I would like, if they have an interesting PR or something that they think would benefit from me code reviewing live, and you're the author, you know, go ahead and tweet that at me or something. We could give that a shot for some other stream. I think that could be cool. Okay, so what happened this time? So unfortunately that didn't really do it. We ended up with this again. So let's go ahead and debug. Yep, you are correct. Thank you, Aditya. And that is why we have debuggers. All right, so let's see if that worked. Maybe it did. So I'm hoping that setting this flag is enough to get it to find the annotation. Which it seems like the last time I wasn't actually setting it. Because Boolean logic is hard. Okay. All right, and that looks like it worked. So we're now correctly getting the stable field here. So this isn't so bad. I mean, it bums me that we have to have this plugin. It would have been nice if we could have avoided that entirely. But overall, I mean, this plugin at least is like not doing very much. But we'll have to like consider what the I don't know what the deserialization cost is to having this flag always true. Like it, just intuitively, what it seems like it means is now basically every class that you're linking against. Every class that you're linking against from another module where that module has been compiled by the Compose compiler, each one of those classes, it's gonna have to go and look at the class to see which annotations are there. So that could be a sizable cost. I don't know. I mean, the class file is already open, so like it's already reading all these other things. So like it may just be pretty negligible, which is what I'm hoping, and we'll have to investigate that at some point. But this at least is like a functioning sort of full circle here. So where's this? So if we go back to our transformer, adding the annotation here, and then adding the field, which is pretty simple. And then we can kind of get rid of a lot of what this class is doing, because instead of inferring it this way, which there might be some value to doing this, but for now, let's see if we can get away from that. So yeah, I think so. So basically, we don't need this stack, and we don't need to do these other things here. I wonder, am I able to do that? No, it needs to be an IR class impl. Okay. Declaration. Oh, actually, I kind of want to keep what this had. So we'll do this. And I kind of want to have, like, basically I want to use the same stability of that I'm using for everything else, basically. So I'll say declaration dot default type. Yeah. And so here's the interesting thing is I should be able to like get chained stability here. Also, I'm not sure why, but the expression body wasn't showing up. Yeah. So what I want to do here is the initializer. It's actually like this. So higher stable equals stability. So now what I can do is I can generate an expression that is the stability of this class. And I can have the initializer be equal to that, basically. So then I can just put that here. And this could be null. So if it's null, then basically I can't, the class isn't stable then. So in that case, we don't add the annotation, and we just return. And then there's other there's other cases where we won't want to put this flag on it, and we should enumerate those at some point. But for now, like this is like a good start. Which, I mean, one thing is I do like how simple this transformer has become. Like, since we're not doing a lot of the inference, like we're not doing as part of the visitor pattern, and so I could easily take this and move it into another transformer, so we don't pay like the traversal cost twice. But for the moment, I'm going to keep it here just because it's sort of more standalone and simple. So let's do a quick test of like what we just did. Comp fun transformer test. We have some tests. Okay. Like, one of the things we might want to do is expand these tests so that they can be multi-module. Because, I mean, a big part of this whole feature is related to how this works across modules. And so we're going to have to test that like pretty thoroughly. So I wonder if we can do that. Oh, you know what? The whole type parameter thing, we're gonna have to deal with that individually as well. I wonder if we need to encode that somewhere in the annotation. I'll think about that. Andre asks, do you think it is possible to have similar multi-module tests with the JS backend at the moment? I don't know. What we're doing with the multi-module test is like very JVM specific. Like we're doing some nasty stuff with like class loaders and all that. So I think a lot of it wouldn't apply to, like, I think having the tests that work the same way, it sounds like it ought to be possible, but the way to accomplish it would probably end up being pretty different. Because we like end up writing files to some directory and then, I don't know, just doing some kind of haphazard stuff to get all this to work. I mean, it works, but I'm not necessarily happy with the way these tests work. Yeah, I mean, in general, like in the main compiler code base, it seems like the tests for verifying like across module behavior aren't that thorough. So early on in Compose, we had a lot of issues that would only manifest themselves across module boundaries, and I don't know, testing it was difficult. So I'm wondering, like here, so we've got this compile. So we compile everything except for the main, and then when we do the main, what do we do? I guess we just have this directory and it'll, like, that's on the class path, and that'll work well enough, I guess. So I think that we could do gen test files. Let's see. Let's try and do this. So here's the transform test. This would actually be really helpful just to have the ability to run these transform tests against some other module that's fully compiled. So okay, so I do this this verify compose IR transform. I kind of want to create like a similar method to that, but this extra maybe would be from a different module. So we'll say let's just call it like this, like verify cross module compose IR transform. And so we'll say dependency module source, or maybe just dependency source. Okay, and so then in this case, I think we kind of want to do what this test does here. This is kind of gross. Okay. Gosh, yawning a lot. I guess this is from a different. It's from a different base class. What is this? So this is an abstract compiler test. And then what I'm an abstract compiler test. Oh, okay, so that is there. So what about the setup file or function? So that's local. This is calling the abstract code gen test. So I wonder if I just implement abstract code gen test instead. Am I gonna ruin all these tests? Code gen test. So now this setup function is there, and the class loader function is there. What was value here? Oh, okay. So this is just the string. I'm gonna add the dump classes boolean here, which is just something that we have in kind of all of our tests. Is like if you want to dump classes, it'll just dump out the bytecode of whatever it generated before running the actual test if it can, so that if it fails you can kind of look at the bytecode. Hi Bakiri. So then this will be where? Okay. So we're looking at this. So this is in a way is like my library class. Validate. What does that do? Oh. That's, I see. So it's just passed in. All right. So basically, I guess we're done. So the class loader, I think, should should end up looking in that directory. Class loader. So string boolean. Source file name. I see. So I guess we need to give it a file name. I think we have a method to do that. So hold on. Stat. Test file. So I guess I can just make a source file from this. Dependency source equals source file. Oh, but I still need to give it a name. What does this do? I thought we had like a utility for making a unique file name. I see. This is kind of janky, but sure, why not? Val dependency file name. Okay. I'm gonna put it here. And then where did the class directory come from? So that might be like the trick here. Oh, okay. Test local unique KTX. All right, we can just use that. Which again, looks a little bit janky, but that's all right. Interesting that additional paths got copied. Oh, both of these did. I think I had copied them instead of implementing abstract codegen test. So I think that'll work. Okay, and then so after I set up, I think, so we'll have to try this, but I think at this point, then I can just verify the single one. And it'll grab the classes that we just compiled off of the class path. So I'll just pass these in as if, you know, we were doing it before. So for extra, I'm just gonna do an empty string and then dump tree. So let's see if this works. That would be surprising if it worked, but maybe it will. So now in our class stability transform test, like assert transform, it was just calling this verify compose IR transform. So we can just do something like this. Test, or what do we want to do? Well, okay, that's fine. Verify cross module. And so then this is going to be from the one file, or like that'll be in a separate module. And then this will be the module that we're like testing. So composable fun A, let's just do what like the example we did before. A foo. And then this will now be the like printed output of this. Composable. Okay, and so then I'll say test empty class across modules, something like that. And then we'll need to, so I'll need to give this a package. So I'll say like package A, and then I'll say import a.foo. All right, let's see if this works. So stack was renamed. Yes, it was. Do you disagree with this change? Temperature. Let's just call that internal. Looks like this was defined multiple times. Okay, so we can remove it here as well. Oops. Enter. Okay, should be fine now, yeah. That's why it's called a stack of cards and not a box of cards. Yeah, it's a good argument. I don't really have much skin in this fight, in this game. Is that the phrase? Yeah. So I don't know. I read the proposal. It didn't seem that crazy. Seems like there was some user studies backing up some of the justification here, and it also, you know, reduced the number of concepts that we had. You know, basically people were using box a lot in situations where the stack would have been like both worked, but like stack would have been a little bit better. And so we ended up, you know, thinking that this might push people to do the better thing more times. But I mean, I like both names, stack and box. You know, sometimes, yeah, box is like the thing I'm going for, and other times stack is what I'm going for. And I can see the argument that when I want like these, you know, Z stacked kind of views, that stack might be a term that I reach for first. But, you know, in any event, like I think It's not that big a deal to me. We do now have two box elements, one that is stacking, one that is the old box, like colored rectangles. Well, we have two box overloads, one with children, one without children. But the one without children is what you would get if you passed in no children to the one with children. So like, it's just a convenient way to get a layout element with no children, which is something that you often want to do when you just want to have like a, you know, some sort of like a rectangle or whatever to put some modifiers on and do some things with it. So the breaking change, I guess, was that like before box had a default layout policy of column, and now it has a layout policy of like what stack was, meaning that basically there is no layout policy, it just gets placed, and that can be more efficient in a lot of cases. But I mean, so to be clear, like I was someone who pushed hard for box to get a default layout policy of column, just because I think it's just a sane default, but I don't feel strong enough to, you know, fight this decision or anything like that. Okay, so it seems like it can't find A, which is what would happen if this source like didn't exist. So this is not getting loaded on the class path. Which is not surprising. I just need to kind of figure out what it is that we were doing in here to make that happen. So I guess we must have been doing something. I'll generated files. Yeah. I mean, so I guess I wonder what class loader is doing. I see. So default class path. So I feel like that didn't really tell me much. Generated classes in file. Okay. So were we setting this? I don't remember. I guess we have this. Which this is, okay, this is the abstract compiler test. So we null out the class file factory after running this. And then calling setup, I suppose, is supposed to set some of this up. I guess this probably does it. Class path. And then there's additional paths. So I wonder, are we implementing that? Yeah, okay. So this is probably the trick here. So here we want to do that. Okay, cool. I wonder if that'll work. Let's give it a shot. Just complaining about something. Classes directory cannot access. Oh, we don't want to put it there. We want to put it here. Got it. All right, that might work. Classes, oh, okay. Sure. I'm excited. I think this might work. All right, it worked. Sweet. Okay. So, this is really cool. I'm like, this is gonna make testing this way better. Okay, so it looks like the source printer is kind of doing some weird stuff here. So like we probably want this to be like that, but it wasn't. So let's go fix that. Our source printer. And then this is probably going to be like visit get field. Yeah. Okay. So if there is no receiver, then it's a static field, which like there's probably like, unless we're in the class, we probably want to print out like the class name as the thing. And even if we're in the class, like it's fine if that's there. It'll still look pretty reasonable. So we'll do that, and then we'll say, we'll do this. And so if we don't have a receiver, then what we want to do is get the that symbol, that owner, and then so the owner is the field, and so then we want to it's interesting. I guess we can say if expression symbol owner. Let's just get the owner here and set it in the thing. So we can say if owner is static, which I mean I think it always will be if the receiver is null. Like I think that the only option is that it's static, but just in case, that's fine. So then we'll say parent dot name, and that should be the class. We can say parent. Will that have a name? Yeah, it will. Okay, so then what I want to do is just say print parent.name. And then this could technically fail. Let's do this. Parent is IR class. Sure. Okay, so that now I think should print the right thing. So let's run it again, see what happens. Sweet. Okay. Akiri says, out of context question, how can I see the source code of compose functions in Android Studio? I can only see the decompiled code. So yeah, I think there's a bug in the latest Studio Canary where so from my understanding, there was like some code in Studio that would like automatically attach sources for some modules or some jars and stuff like that, but it seems like people thought that this was like that code wasn't really being leveraged anymore. But it looks like it was, and so like for some reason, it seems like all of Android X or all of Gmaven, I think, the jars being pulled from Gmaven don't have like the proper metadata to get Studio to automatically connect the sources. So this isn't a Compose specific issue, but it is like a pretty serious issue, and I think they're trying to resolve it. So hopefully it'll be fixed soon, but. It is a known issue, and I'm not sure what the status of fixing it is, but that's what I know. Okay. So this is really freaking cool. Yeah, I'm really happy with myself right now. Let's start playing around with this a little bit. Like, so basically, we should be able to have like, let's have 2 of these, and like this should. The question is now, what will this do? And I think it'll do the wrong thing. I think it's going to say foo.stable and bar.stable. But what we need to do is we need to shift the bar.stable to the second parameter. And actually, so we can do something. Let's just do this, right? So in this case, like x is sort of known to be stable, and it's an int. So we should be passing in nothing for that. We should think about that actually. That's a little bit. Well, I think we'll pass in a constant for the stability there, but that's a case where the type of the function is sort of required. Like there aren't any subtypes of int, so it like kind of has to be stable. We should think about handling that in like a more efficient way, maybe. Oh, I guess I gotta import it. Makes sense. I mean, one thing I could do just to make these tests a little bit simpler is I could just always insert package A and then just import a.star always. Maybe I'll think about doing that. But it's not a big deal to write it all out right now. Okay, so what we end up seeing here is this. And so this, basically we can break this expression down into like 2 pieces. So there's this piece, right? And so what this expression is basically saying is like everything that we know about the x parameter, pass it in so that the next A knows everything it can know about that parameter as well. And then what we do is we OR that with this expression. And so this expression is supposed to be about the second argument to A, which in this case is bar. And so what we're saying is that we don't really know anything about bar except for that its stability is determined by this. But the problem is that this is now, like, we're not shifting this at all. And this is for the second parameter. And so we need to shift this so that this expression ends up in the right sort of slot. So let's try and work on that. Where is this kind of so here we want the build changed, which, okay, so for the other stuff that happens here, like the we're doing the shifting in this place by doing some mask shift bits from this slot to that slot. So what we want to do then is we want to shift this expression on our own, or like independently. So if the expression is non-null, then what we want to do is shift I wonder if we should just write the code directly. So let's see, we start out in slot 1, or slot with index 0, and we're always gonna shift it left. So let's just do this basically. It's per slot. Hey Nicholas, thanks for saying so. I enjoy making them, so it's it's kind of just like me doing my job, talking out loud. But I don't know, there's something kind of fun about that. So I'm glad that you like them. So now we have this call, and it's always going to be shift left, I think. So we'll grab this. Whoops. So that goes there, and then it is our expression. And then, so this constant here is the number of bits that we want to shift left. And that is going to basically be the slot, right? Yeah. Because this, so the slot, this is the parameter index. And so if it's 0, that's, then we shift 0. Okay, so let's say bits to shift left equals index times bits per slot. And then, oh, sorry, slot. Basically here we'll say if slot is 0, then we're doing no shifting. So in this case, we just return it. Otherwise, we do this. And then this ends up as bits to shift left. And I think that's all we need. Type match. Oh, okay, yeah, that's fine. And then here we add the expression. So I think that will work. So Aditya says, I have a weird question. Both Compose and Flutter draw on Skia canvas, so it's theoretically possible to convert Flutter draw calls to Compose and vice versa. Let's think about this. So I mean, I'm not exactly sure. Like I understand what you're getting at, but I guess I'm not sure if there would be any actual utility here. Like the whole point of Flutter, like all the machinery of Flutter is really just to boil down, like it's to take code that's like declarative and like in this kind of component-based style and like reactive with like this state management and all this stuff. It's like to boil all that down to like draw calls over time. But once you've boiled it down to draw calls, like I don't know what that would mean to convert that to Compose. Like at that point, all like Compose does the same thing. It boils down all this code to draw calls. And so there's I guess there's you're like in a different format. There's like, you know, declarative stateful widget land, and there's draw call land. And, you know, one is a lower version of the other. And Compose and Flutter both do that conversion. But once you've converted, there's no value to going back over to this format. Like either, you know, Flutter or Compose. Like I'm not sure what you would gain. And so, you know, they're both targeting Skia, but that's like at that point you're in the draw commands already. So whether you call Compose's Skia canvas or Flutter's, it doesn't really matter. I mean, one difference is like Flutter bundles Skia with Flutter. So they're using their own version of Skia, which is like fixed for Flutter. Whereas Compose attempts to use the platform's underlying canvas implementation, which uses Skia under the hood. But we tend to we try to create our own sort of canvas abstraction that ends up calling to the platform canvas, and you know, and that's like one difference between us. But like, if the versions of Skia were equal, then you know you could pass those commands to either. But there's no like kind of converting it to Compose. Like it doesn't really make sense to me. It's a weird statement, I guess. Not sure if that makes sense. Let me know if that makes sense or not. Okay, so our test now returns this. And so you can see that the key thing that's changed is this. So now the bar.stable is getting shifted by 3 bits. And what that's doing is that's now aligning this stable constant with the index of the parameter that it's referring to, which is 1, and pertains to y. And so this now looks like it's working correctly. Now the interesting case here is like, what if we did this list of bar? This is gonna be crazy. So let's just do that. So now, I mean, eventually we'll split these out into separate tests, but I'm just kind of playing around to see like what works and what doesn't. But what I would want this to say is that this parameter is stable if bar is stable. Or actually, I mean, like maybe so. Well, let's see what happens here, because I don't remember if I wrote in some. I think I did. I handled list of specifically. Let's see where that happens. Yeah, no problem, I did too. So, where's the abstract compose lowering? Computer's really struggling right now. All right. So, one of the things I do, I think, is, yeah, so when I'm calculating the stability of something, if it's a call, then there are some cases here that I check. And so I added this case here for when the call is calling something that's in the Kotlin standard library, then it goes down a slightly different path. And I'm special casing some things here. So like list of and list of not null. This is kind of nice. Like basically what I've done is I've kind of hard coded the fact that the stability of list of is really the stability of the element types. And so I'm grabbing the single argument to list of here, and I'm returning the stability of it instead. Which I don't know. I think this will end up working, which is kind of cool. Oh, it did not work. That's interesting. So let's figure out why this didn't work. So I mean, it like, so what it ended up doing was marking it as stable, which is a little too aggressive. We only want to mark it as stable if bar is stable. So let's try that out. So we're debugging this time, so I think that this will should trigger something. Here we go. So let me see, what are we testing here? So we're okay. So this is probably happening as we're compiling this package, which is fine. So we'll get stability of foo, stability of bar, and then what should happen is we should get the stability of this expression, and then we'll assess the stability of bar while we do that. So that's foo, this is bar. Skycolor asks, are there any upcoming features for Alpha 5? I mean, there's always new features. Trying to think if there's any in particular that you know, I'm really excited about, but I don't know. I've been pretty stuck in either compiler land or like refining the APIs that already exist, and not much in the new feature space. But there, I mean, so there's something that I'm working on, which I won't talk about explicitly just yet, but there's something other than this that I'm working on that I'm really excited about, and I'm also just really excited about this. I think that this is going to have a huge impact, just absolutely huge. There's another thing which Chuck is working on, which will is potentially re-implementing a lot of the runtime in a slightly more efficient manner. At least that's the hope. And so he's sort of in the home stretch of that, but like basically what we're doing is the slot table for the compose runtime right now. Basically it's an array. And because of that, a lot of the runtime ends up storing a lot of ints in this array. And so because of that, like these ints get boxed a lot. And so there's a lot of boxing. We do a pretty good job about not boxing on recomposition. So like if nothing changes, then we don't like box the integer just to compare it with the already boxed integer, if that makes sense. But what we're gonna try and do is have the runtime essentially have like two parallel arrays, and so there will be one array that's just an array, and that holds objects, and then there will be an int array which just holds ints, and they'll sort of, you know, be of the same size, and we'll actually they won't be the same size, I think. But this is allowing for us to one kind of compress the slot table pretty significantly, I think, and also avoid a lot of boxing, which is helpful as well. So we'll see how that goes. He's still not completely done with it, but I think that'll be pretty cool. But like again, that's not really a user-facing feature, so hopefully that all lands, and it's not even a breaking change in any way. I just find it interesting. Danny asks, is it to make the performance as good as the current view system? Well, it's just to make the performance better. So it's hard to compare it to the current view system. Like in some places we're a lot faster, and then in other places we're slower. But just in general, we're just trying to make it perform faster. And this was one of the ideas we had to do that. So yeah. Okay, so this is the stability of any, which we don't care about. So stability unstable, what is this? I see. That's fine. So now this is list, stability of the list. Okay, so we're inside here. So first we get the stability of list itself. And list is technically like strictly unstable. So this should return unstable, which it does. And then now we're getting the stability of bar, which also makes sense. So we're in here. Where are we getting the stability of bar from? Type that. I see. So we got into type argument. Okay, so we're doing this here, which this isn't technically correct, but it's fine. So that will happen. And then, oh, interesting. So it didn't make it down that far. So in the stability of IR expression, we never, oh, I see. So this is a little too aggressive, I guess. I think basically we return this. Okay, yeah, it was a little too aggressive. I thought that if it was known unstable, then we could just return, but I might have to be a little bit more specific about the known unstable function. So Danny says, actually, that's a good follow-up question. How does Compose compare to the current view system in performance? So it really depends on what you look at. I mean, there are like in general, it's pretty good. I think we're better in like most cases, but there's still some that like we definitely wouldn't be. And it's hard to figure out what the apples to apples comparison is. Like, you know, with the current view system, you know, there's the question of like, do we compare it to people using XML layouts with like layout inflation being part of the cost, or do we compare it to just code that is like dynamically creating new views and like constructing a view tree? So like those are some weird questions. And then there's also like new factors that we need to consider. So like for instance, if we want to create, like we can create a view tree with like you know, like let's say it's got like 10 text nodes and 5 checkboxes and, you know, a text edit or an edit text and, you know, a few buttons, like whatever, like there's some layout that has like all these things in it. And like, it's just a layout that's there. And like, maybe we, you know, we write some code that does some state management or whatever. And it gets a little bit weird when you're comparing these things, because we can, with Compose, we have like composition cost. And so there's things that you're managing inside of a composable function that is a little bit hard to map to like an equivalent in view land, because you've got like you've got different state management techniques and like whatever, and so how do we account for that cost? But so anyway, I mean, like there's most benchmarks that I've seen, if you write like good optimized compose code, we usually win. But like that same code, I could change in a way that might make it lose, but it's still doing like kind of the same thing. And so one of the more difficult parts is like finding good comparisons. And so typically we end up on like one of the two ends of the spectrum. Like we can have like really like kind of obvious tests that aren't they aren't necessarily realistic, but they give us something to compare against. And that would be like, okay, let's render 1,000 text views and compare that to rendering the same 1,000 text composables in Compose. And like, what does that end up doing? And so then you kind of take like the dynamicism and stuff out of the mix, but you're just saying like, okay, what does this cost? Or, you know, like 1,000 checkboxes versus checkboxes, or, you know, button versus button. Like there's some things there that we can check that. And then, so that's at one end of the spectrum. And then we sort of test at the high end of the spectrum, which is like, okay, let's have this like whole app, right? And let's just see like, okay, maybe there's this app with like a news feed or whatever, and like it has these basic elements, and then we compare like scroll performance with you know, like one feed versus the other, and like, and so then it's not necessarily like 100% apples to apples, but at least like we're like, okay, both of these apps were built kind of in good faith, and it's like they have roughly the same functionality, and like you know, haven't done a bunch of like clever tricky things to like ease out performance. It's just, here's this basic thing, and like how do they perform relative to one another. And so we're kind of trying those two approaches, and we've got like some benchmarks with some with kind of both of those scenarios played out, and we're trying to build more benchmark cases to do that. But yeah, and I think we're doing pretty good for like where we are in the pipeline. Like I assume that there's still quite a bit of low-hanging fruit in terms of like improving performance, and I think we're already better in a lot of cases. So yeah. Okay. So this worked. The result of this was this. And so this is pretty cool if you think about it. What we've got here is we've got this composable function, which is accepting any, which currently would absolutely never be stable. And we're passing in, oh, my mouse just disconnected. Let me get my mouse back. Weird, did it just die? Okay, let me get some new batteries real quick. All right, Got some new batteries. Let's see. Okay. This is not. Nice. I don't know what's going on. My mouse is not connected. Oh, there we go. All right, mouse is back. Thank God. Okay. Nicholas asks, this playlist you're playing, is it perhaps public? Unfortunately, it's not exactly. Like I have a playlist through this service called Pretzel Rocks, which is like a streaming music service. But if you go to my Twitch page, when Twitch is active, you should be able to see there's like a button or something on the right hand side of the Twitch stream, which will show like what the current playing song is and all like the previous songs in the queue, and I think it'll have like links to them. So it's like kind of like a playlist, but it's not on like a service where you can easily use the playlist like Spotify or something. But I don't know. I'll maybe consider a different option there long term. Also on the bottom left of my stream, it'll show like the current playing song. Hope that helps. But okay, so back to this. Like we now, this is pretty cool because this any parameter, which previously would have like absolutely been unstable and always unstable, now what we're doing is we're passing in list of bar, which list is an interface which is not it's like not possible for list to be considered stable in general. And then bar, which is this class defined in another module. So both of these classes like not normally safe to consider stable at all. But list of, we know that list of returns an immutable list. So we can say, okay, the stability of the result of this function is really the stability of the values, and the values here are of type bar, and in this case bar then is its stability is determined by this stable flag, and so then we pass in bar.stable here, and now that made it so that A can be skipped, which is really cool. I'm pretty happy about that. So let's try something even more complicated, which is like, let's say that bar has a type parameter, And so it's got a type parameter, and the stability of bar sort of depends on the stability of this type parameter. And so now we're going to say bar of foo. And so what I would want to happen here is that this ends up being basically bar.stable and foo.stable. Which so that won't be the case currently, but so we're gonna have to do a little bit of work to make that possible, but that'll be sort of the next goal. However, it's about 12:30, so I've been streaming for about 2.5 hours, and I think I'm gonna end the day on that, since I feel like that was like a nice small victory, and I'm getting a little hungry. I want to go eat some food. So appreciate all of you for coming and tuning in, and I'll see you probably on Sunday, I guess will be the next stream. So come on by. We'll be doing, we won't be working on the compiler. We'll be doing the composed dog fooding, working on the movie app. So if that sounds like something that interests you, come on by Sunday, and I'll see you then. Thanks, everyone.